This is our demonstration of pspin. This is a simulation of the RISC-V based spin SmartNIC, and the simulation is done using a project called Verilator that does cycle accurate simulations of Verilog source code. On the left side of the screen you will see what we do in terms of compiling code, so what are the commands that we need to enter. On the right hand side of the screen we will show the source codes that are being compiled. In this example you see a synthetic benchmark packet handler. So in this instance, every time we receive a packet we execute a configurable amount of DMA requests both from the host, from the SPIN-NIC, as well as to the host, so DMA gets and puts, while we are sending a configurable amount of packets to a remote node, so basically causing a lot of traffic between the host and the NIC and overlapping this with network traffic. You can see the commands spin DMA from host, spin DMA to host, and spin send packet. On the left hand side we are now compiling this code. This should be pretty fast. And once the code is compiled, we can actually run this. But of course, to run this, we also need to simulate incoming packets. You can see such a incoming packet trace on the right-hand side. And you can see we are receiving in the simulation multiple packets from different sources. So the source is the IP address on the left with some delays. Now on the left hand side you see the running simulation, so the simulation also prints what is happening, so essentially the same trace that you will see on the right hand side as it is read and executed essentially. We are accelerating this part here a little bit to keep the demo short. Once the execution has completed, we have a complete trace of the instructions that were executed on the simulated spin NIC, and we can use actually the trace visualizer built into the Google Chrome browser to visualize this trace nicely, which we will show now. Within this trace we can zoom into the different cores. So in this example we are simulating multiple cores, and we can see how long each part of the handler actually took to execute. And this is a cycle accurate simulation, so this is perfect for optimizing handlers.